And we are live. Sorry, I'm still a bit sick, but that's fine. So, we are gonna continue where we left off last time. And by the way, I got the hardware, not all of them, but I have the motor with me. I also have the controller. It's right here. Here's the switch. So I have most of the hardware except for the power supply and the inlet, the power inlet. These should arrive like in the next couple of days. So I should be able to test this thing very soon, hopefully. What is left to do is um, basically what's gonna hold the lures. And um, I'm thinking about multiple things because since we have these screws here, we can have multiple attachments, and that's like the goal, right? So we can have only one lure going here from here to here, or we can make some sort of a wheel, like a big wheel. And by the way, is my audio okay? It should be fine. I have some new hardware I'm testing. I think this should be closer, something like that. Yeah, this should be better. Yeah, some sort of like a wheel where we can attach like 5 or 6 lures at the same time, and it will spin. The only issue with that is it will not work with UV resin, so it will only work with like regular epoxy. So with UV resin, ideally we would want like only one lure here that's spinning around this line. So spinning around itself, something like that. So we can, I guess, we can keep this idea, this lure holder, for one lure, and then do the cylinder thing for multiple lures. Do we have any other ideas though? No, I think this will be enough. So yeah, I'm gonna do the cylinder thing. We will do the cylinder thing. Let's start. So to do that, what I'm thinking about it's gonna be like, let's say one cylinder here, and then it's gonna be mirrored to the other side. So two parts that are mirrored, and it's gonna be some sort of a cylinder with like a cube or something coming out of it, like a rod, and then it's gonna be mirrored to the other side, and then somehow we need to attach them together, probably using a dowel pen or something like that. We'll see. We will see. Okay, so we need to create. Come on, deselect it. Yeah. We need to create a new body. And let's rename this to, what do we need to call it? Let's say multi-lure holder. And we need some parameters for this. So we need to create a spreadsheet. And this one will be called, oh wait, I wasn't using spaces, so I need to be consistent with the naming. Come on. Okay. Multi-lure holder params. Cool. So obviously we need a diameter. And let's set this to something like 100. We can change it later. We need the thickness. Let's say it's 5 mil. We need For now, let's do this. But thickness 5. This is very thick. Let me see how thick this is. We can measure it from here to here. It's 15 mil. So how do we want to deal with that? I guess we don't have to. As long as we have enough clearance for all of this to go inside of it, then we're fine. So let's clear this. So we have diameter, thickness. There's gonna be a rod. Let's call it rod width. Let's do it something like 10. Oops, no 100. And of course, we also need to define the aliases for all of these. Thickness, cool. Rod width, nice. Let's leave it at this for now. And I need to move this up. So at the moment, the origin for this new body is down here. So we need to move it up all the way here. And to do that, we need to change the position or the placement position in the Z axis. It's, if I remember, oh, sorry, I have to go to the formula editor. If I remember correctly, it's general.height minus, 1 second, it's been a while. General.height minus motor holder params dot motor diameter divided by 2 minus motor holder params dot motor offset from top. And what was the thing? What was it called? Motor pin offset. Let's see. Yes, it's exactly in the center. This is what we want. Cool. Cool. And I want to start right at this line. So right where the threads stop. So I'm going to move the x-axis. So the x position, let me just make sure it's the x, yes. We want to move it by how much? That's going to be a tricky one. Oh, that's going to be a tricky one. It doesn't have to be exactly there, but let's see. So if we get the general dot thickness, then we're going to be right here. Now, just to remember, we measured 15 millimeters from here to here. Where does this number come from? It came from the rotating screw params, I think. Screw length was 15. Bearing width was 4. Okay, so what is the distance between this line? So let me measure distance between this line and this line right here. It's 4.2. 4.2, I think that's the bearing width. Where is it? Rotating screw params. That's the bearing width plus 2 tolerances. Yeah. So let me clear this, and now we need to move it. Here we need to add the bearing width plus rotating screw params dot bearing tolerance multiplied by 2. And now we're at this line. Now, just to be sure, I want to be 100% sure. If I change this, set it to 0.2, for example, what's going to happen? It's going to take a while. No. So is it the regular tolerance? It might be the general tolerance. But if it's the general tolerance, then is it? Okay, so if I go to general and change the tolerance to 0.3, huh. Okay, something is off here. Something is very off, but I mean, it doesn't have to start from this. This is just a visual thing. So for now, I'm gonna set it at 0.2 and just assume it's correct. It will not affect anything when we actually print it. But now we have the exact location where we want to start from. So, come on, what happened here? What happened here? Let's recalculate. No, it's failing. Interesting. Moving platform. So it failed here somewhere. Let me hide bearings, screws. Okay. So what happened to you? Okay. This is the pad of this. Results has multiple solids. Okay, I see what's going on. Here we are padding what? We are padding this binder, right? Yeah. So I think, let me copy this. Click OK. Delete this. And then we can just pad this binder. We need to activate the body. I don't know why this keeps happening. This is not the first time. Only with this binder it's happening. And if I delete it and pad it again, it works. However, we do have issues here. Huh. Yeah, definitely need to check that. But this is only happening on both sides. Interesting. I'm gonna ignore it for now and work on this and then come back to it. Okay, so gonna activate the multi-lure holder, create a sketch on the YZ plane, and let's start with the cylinder. So the diameter of this is going to be multi-lure holder params dot diameter. Nice. And now we can pad it by multi-lure holder params dot thickness. And I'm going to give So these attachments, I'm gonna give them a blue color. Something like this, I guess. So the screws are green, and the attachments will be blue. We're gonna have multiple attachments. Nice. Now, we also need to create the rod. So, yeah, did we add a length for the rod? I don't think so. Yeah, rod length. Let's do it at 150. So we need to create a datum plane. I need to show the origins so we can attach it to the YZ plane. And now in the Z direction, we can move it by multi lure holder params dot thickness. No need for the origins anymore. And now on this plane, I'm gonna create a sketch. Create a center rectangle. I'm gonna make it a square, so these two sides will be equal. And this one will be the rod width. Maybe 10 was too small. Yeah, I think it's too small. Let's make it 15. Something like that. And then we can pad it by the rod length. Okay, 100 I think is, or 150 is too much. Because we're gonna have two. So one here and one here. Is it too much though? We see. I mean, yeah, 100 and 100, that's gonna be, so 200, 200 in rod length. Basically, then we can put lures up to, I don't know, 150, 160. We can make it bigger as much as we want. I would try like 120, for example. Anyways, so now we have like the basic shape. We have two things that we need to do. One is create like a pattern, a circular pattern of attachments where we can put springs, so we can attach the lures to them, or we can use rubber bands or springs, whatever works. And we also need to add the hole, or the threads, the hole and the threads for the screw. So let's do that. Okay, which one do we do first? Let's do, I'm thinking of how I'm gonna do this. Let's not overthink it too much. First of all, what is this? Pad, okay, cool. Yeah, let's create a sketch on the same datum plane. Right here. And what we can do is basically cut a square from here, or a rectangle. And then, so similar to this, I guess, but not exactly the same. It's 5 mil. Huh. Yeah, could be the exact same. we can have, let's call this the attachment. So attachment hole width, something like that, and then attachment hole height if we need like different width and height, and then the attachment pin thickness. Let's do 3. I think that's all. And the attachment pin thickness. Oh wait, maybe we need some sort of an offset from the top. Do we? Yeah, let's just say attachment offset from top and do it like 5. Okay, so the offset from top, we know the diameter of this sphere. So I can take the distance between this and the top point and say that we need the radius. So the multi-lure holder params dot diameter divided by 2, then we have the radius. Now we remove the attachment offset from top. And now we have the position from the top. And now we can define the width and height. So multi-lure holder params dot attachment width. This is too much. And the multi-lure holder params dot attachment height. Okay, so now we can pocket this through all. And now we need another datum plane here. Sorry, another sketch on the same datum plane. Now we need to create the pen. So we know the thickness is 3. Oh, what about the height? We know where this starts from. It starts from the, oh, come on, what am I typing? So we get the diameter divided by 2 again. We remove the offset from top, but we also remove the attachment height. I guess I'm gonna go thickness or half of this, probably. Attachment hole height divided by 2. And we need to pad it reversed. And we need to pad it by thickness. Yeah, I need to change some parameters. Let's see, let's set the thickness to 2. Offset from top, I think, is fine. And I think what we're gonna do now is let's create a sketch on the XY plane. here. Let's do it like that. Okay, again, diameter divided by 2 minus offset from top minus attachment height divided by 2. Okay, this is the thickness. And let's make these two equal. And now we need to pad it by thickness, the entire thickness minus the attachment thickness. Or we can just go the entire thickness. I don't know why I did that. Not the best, but it will do the job. And it's printable because this part right here, this face right here, is going to be a bridge. So it's fine, completely fine. Now let's see how many. So number of attachments. Let's do 5. 5 attachments. Now we can take the pocket pad and the other pad. So these 3, and do a polar pattern. And the number will be number of attachments. Nice. So now if I want 6, I can just set it here to 6. And we're gonna have 6. So that's out of the way. I mean, do we need this offset? I doubt it. I think it will be actually easier if we do the offset from top. Can I set it like to 0 or something? Yeah. I think with this makes more sense. Maybe we can change the height to something like 8. No, let's leave it at 10. Okay, the holes. Let me just hide some stuff. So we're gonna hide the motor holder, electronic box, fan, motor. Leave the screw. We need the screw. Okay. Let's see. First thing first, we are going to create a sketch on the XY plane. And here we are going to create a hole that is slightly bigger than the screw hole, not the screw hole. So we need to get the rotating screw params dot diameter plus the general tolerance multiplied by 2. cool. And now we can take this. Hi, the slots for the springs better closed. So I don't know if it's better or not, but I have an offset here. I can set it to like 5. Is that what you mean? It was like this, and then I set it to 0, and I think I liked it better, but I don't know. I can leave it like that, but let's see. Pocket. How much do we want to pocket? So we want to cut. First of all, are we cutting in the correct? Or no, I think not. Yeah, now we are. Cool. We want to cut the screw length plus a tolerance. And hit OK. Now to see what's going on, because we don't see anything, let's add transparency to this. And now we can see that, yeah, if we hover over the screw, we can see what's happening. Yes, basically this, they have less opportunity for fork down. Oh, okay, I see what you mean. So it doesn't fall down. Now it shouldn't fall down because of these pins, but I guess if it adds more like protection, then I'm gonna leave it. I will have to test everything at the end, so you'll see. Yeah, so if we hover the screw again, we see what's going on. Now the screw, if we look closely, where is it? So the screw will fit except for the threads. The threads will not fit. So now we need to cut these threads from the part. Are we starting? This looks weird. I don't know, maybe that's a shading issue or something, but it looks weird. Anyways, so now we need to create a sketch on this plane, the YZ plane, and we want to draw a circle right here, somewhere here. Now that's gonna be tricky. This is gonna be very tricky. Because if I remember, this had an offset, something like this. Let me look at the rotating screw params again. Screw turns. Was it here? Interesting. Bearing inner diameter, bearing outer diameter, bearing width. Screw length. So we have the thread width and we have the thread turns. But why is it like this? Oh, it starts from here. Okay, yeah. There is no offset. Right? Because the diameter... No, there is an offset. What is this diameter? Let's close. Let me get the... Oh, we cannot measure diameters here. It's only in the new version. The beta version. We can go to the first screw where we did the additive helix, and here it is. How are you constrained? Interesting. Where are the constraints? I can see them here, but they're not visible here. Oh, okay. That was a bug. It's 5 mil. 5 mil, which is... Yeah, it is the diameter. Very interesting. Oh, wait. Wait. What is this? Thread width multiplied by 0.4? What? And then this is the thread width. So that's an arc. It's not an actual... It's not a circle. It's an arc. This is thread width. And this one is 0.4. And this is the actual center. Okay. I see. I see what's going on. So basically, let's ignore this for a moment, or let's leave it and draw a line on it somewhere here, a horizontal line, and then the distance from this line to the... Wait. Yeah, sorry. Distance from this line to the center is going to be the radius of the screw. Okay, cool. So this point right here should be like that because we have tolerance. Now that is very interesting, but I have a solution. I'm gonna make all of these construction geometry. So all of these are like basically ignored when we're padding. Let's make these two constraint point to an object. And then this one right here is going to be rotating screw params dot thread width. And then the only thing that we need to constrain now is draw a line, or wait, we need the midpoint. We need to create a point here that is basically in the center, and we can do that. We can just take these 2 points and this one and make them symmetric. Now it's in the center. Now we can draw a line from here to here, and then this line is going to be rotating screw params dot thread width multiplied by 0.4. So now we have the old circle. Now we need a bigger one. So we just draw one from the center. But how do we know the radius of this? How do we know that? I guess what we can do, it's a hack, but I think it will work. Something like that. Yeah. 0.2 mil. That's our tolerance. This entire thing is so small that the tolerance looks big. So we need to, first of all, let's make this a construction line. This is also a construction line. The only thing that we need is this circle. So if I close, I should only see a circle. Where is it? Yeah. Okay, cool. Just validating. Now we need to take this and thread it. So by selecting the sketch, we are going to, where is it? Subtractive helix. We're going to use the subtractive helix and give it a moment. Is it working? No, it's going up. We need to change that to the x-axis. Okay, now it's working. And now we need to give it turns, height, turns, angle. So the height is our screw height or screw length. And the turns is the thread turns. And we should, but it didn't work. Huh. Why didn't it work? These should align. But they are not aligning. Is it? Wait. Is it the screw length? No, it's not. It's screw length. Wait. Let me hit OK for now. Let me go to the additive helix. Okay, that's it. Let me copy that. Okay, yeah, now it's aligning. Perfect. Perfect. Let me hide the screw just to see. Where is it? Transparency 0. I want to see if it's easy to start the thread, and we might have a small issue. But I need to test that again, so I need to print it and see if it will thread or not. Because we have this face right here that might cause issues with the thread. Anyways, assuming it works. Now if we print this and then another part, how are we gonna connect them together? I'm guessing we can just add a dowel. We don't have to do any threads or anything fancy, because the what are they called? These things, the the springs. Oh god, I forgot springs. The springs will like push them together. Yeah. So let's go to the here. Let's do something called a dowel width, and do we make it a circular dowel? So So it could be dowel diameter or something like that, but we need also a dowel length. Let's go with a dowel length of 30. And yeah, let's make it circular. So dowel diameter. And I guess 8. So now we need to create a sketch right here. And to do that, we need a datum plane. So we are going to create a datum plane, attach it to the YZ plane. And we're gonna move it by multi lure holder params dot thickness plus multi lure holder params dot rod length, and then we'll end up here. So this will be, it's gonna be bigger than the dowel. So the diameter is going to be dowel diameter plus tolerance multiplied by 2. And now we need to pocket it by going dowel length, but we need half of it, so half for each side. And we also need to add a tolerance. Cool. And now we can create the actual dowel. So just create a new body. Let's call it dowel. I should have made a part. It's too late for that. I could have made a part, and then we could have like 3 bodies in the same part, but anyways. So the dowel, it's gonna be fairly simple. So I'm gonna create a sketch right here. This is going to be the dowel diameter. And we're gonna pad it by the dowel length. Yeah. So we just need to mirror this, or basically print 2 of it. We don't even need to mirror it. And then connect them with this dowel. If you go to attach a round thing in each side with springs, the base can be longer or shorter. I don't understand the mean of the bar in the middle. The bar can be for magnets. No. Oh, you're asking this, like, why do we need this, right? Yeah. So here's the thing. The way I created this, let me try to explain it real quick. So the way I created this is this part right here is free to move along this part. There is no way to like keep it in place. So if you know my previous design, it had a screw to hold it in place. This one does not. The way I'm thinking about it is basically the springs will be pulling these two together. So without this rod, then they're gonna just keep pulling and the lures will fall. That's why we have this rod. So we're gonna have two of them, and then with the power of the springs or the rubber bands or whatever that's pulling these two together, it will stay in place. That's basically what's gonna happen. Now, also another thing that will keep it in place is the screws right here. So that's another thing. Again, I'm still experimenting with this, so anything might change, but for now that's the plan. So we're gonna have a screw in here, we have a screw there in case you want to extend it. We have a third screw here attached to the motor. So one part is going to be screwed to this one, another part will be screwed to this one. And yeah, do we even need this to be circular? I don't think so. I think I should have made it. Where is it anyways? Where's the dowel? Oh yeah, we need to move it. We need to move it by on the y-axis, I guess. Somewhere here. So let's go by oops. No, more. Let's do 30 or 35. Yeah. I hope I explained it well to you. But yeah. I mean it's gonna keep it in place even without the springs. No, the springs are needed. And we can even add more springs at the bottom to make it stable, because the previous one it was doing this. Whenever you put a lure, it sometimes bends like that. So maybe with like springs at the bottom and springs at the top, maybe it will be more rigid, in addition to these screws and the dowel and everything. Maybe I'm over engineering it, but but that's how I see it working. This one I will not need it for now. We have bearings, yeah. We have everything showing. Did I miss anything? I feel like I'm missing something. Yeah, I'm gonna change this. So instead of diameter, I'm gonna call it width. Dowel width. Let's rename it here. And multi-lure holder. Let's go to that sketch. I'm gonna make it rectangular. So double width plus channel the tolerance multiplied by 2. and these two will be equal. This way we have the orientation of these faces aligned on both sides. Now we can go to the dowel, do the same. Make them equal, and this one will be but if there is not screw in the base, the springs of them must be extension springs. I don't know what you mean by extension springs. I'm thinking something like this. Wait, I don't think it's visible. Let me turn autofocus just really quick. Something like that. But this one, I accidentally ordered one that's super stiff. Like it's very strong. So I need to order some stuff that is a bit less strong than this, because this will for sure break the plastic. But that's like the idea. We have springs like this going from here to one side of the lure, and then another one to the other side, for example. And yeah, of course, I'm gonna have multiple versions of this. Like for example, at the moment the rod length is 110, and this is for like big lures. If we want smaller lures, then maybe we need another version that's 80, and then it's gonna be smaller. This will be like for smaller lures with smaller springs. This is a compression spring. Oh, now I see what you mean by extension springs and compression springs. Yeah, and you need to hold the base in anyway. Yes, so we're gonna use compression springs to hold the lures, and this will also automatically connect the two blue parts together, like compress them together. And then I don't know if we need any compression springs down here to connect these two. I don't think it's even necessary. But yeah, imagine you have like two or more of these, of this one, moving platform, the green one. Imagine you have two or more, and also the base, you have connected like 3 or 4 of them together. So it's like one big turner. And then you can compress them together using springs. And for each one of these, you're going to have 2 of these black parts, blue parts, sorry, mirrored to each other. And then you can run like how many lures? Each one of these is 6, I think. We can make them, I think 5. What happened? It crashed. Oh, come on. Yeah. Multi-lure holder, number of attachments. We can have them 5, I think, is better. So we can have a bit of space between each lure. So 5 lures on each of these turners. If you run like 3 of them, that's 15 lures turning at the same time using the same motor. You can have like 5 here, 5 here to the right, and 5 here to the right. You can basically add as many as you want. And this motor should be powerful enough. It's bigger than I thought, by the way. I thought it was a bit smaller, turned out to be a bit big. And this is a high torque motor, so it should handle the torque no problem. And with the bearings, there's there's not enough, there's not much happening, so it's very smooth. And that's gonna be, wait, that's gonna be like the knob to control the speed. Also, this is a lot bigger than I thought. And we have the switch also to go counterclockwise, clockwise, and off. So yeah, I think it's gonna work. So I should be able to start. I should start to build this in the next couple of days. I will update you guys on Discord about the progress. I'm still waiting for the power supply to arrive because I don't even know how to mount it yet. There's gonna be some holes, but I can't find online like the schema of where the holes should go and stuff like this. Also, I need to mount this. Interesting. Yeah, so I do know where the holes of this one will go. It's so I need to do that, but do we have enough clearance? I'm gonna measure this. Let's see. Let's do it now. What was this called? Electronic box params, power supply, switch knob, board width, board height. Here, let's measure the height. So the height is 27 mil. Let's see how it looks. That's very close. That is very close to, wait. I hate navigation in FreeCAD. It's so bad. Let's start turning these off and the water holder. Moving platform. Yeah. No, I think it's fine. Yeah, it's not that bad. And I mean, the big part is in the middle, so it's gonna be down here. Up here, there's nothing. No, it's fine. Yeah, it's gonna work. It is going to work. Oh, okay, I see what you mean. We must hold the base. We must hold the base. You mean here? Connect these to this? Or what do you mean? I don't get what you mean. If you use springs to hold the lures in compression, you must hold the base in a position which keeps the extension strong. I mean, the lures will compress the forces happening on the on this. Let's do something. Wait, let's do something. Let's clone this. So we have another body, or wait, not clone. We need to mirror it. Can we mirror in part? I think workbench, we can do a mirror. So we can mirror this. Oh, come on what plane? No. On the Y. YZ plane. Interesting. What the hell is going on? I have never used this mirror feature before. Oh, okay. Let's just delete it. Anyways, what I wanted to say, the forces of the compression are gonna be this on this face right here. So these two faces on each other. It's gonna be pulling this platform, of course. It should work just fine. I don't know why it wouldn't. I don't think there's a need for anything down here, but I will see again. Once I yeah, no, it's not like that. Maybe I'm not also understanding what you're trying to say, so we'll see. Now I'm stuck here. What happened? I didn't even save. What the fuck? What the hell is this? How do I delete it? Edit mirror plane, no. What? Okay, let me save. And let's exit this. And start it again. See what's happening. Okay. I don't need to mirror anymore. Okay, now we're back. Let's save it. Cool. Yeah, anyways, again, you might be saying something, I'm not understanding it. So it's fine. As I said, I'm gonna be sharing updates on Discord very soon. I'm just waiting for a couple more parts. They should arrive this week, and hopefully this will work. It will definitely work. Anyways, so that's all for today. If you have any questions, just send them on Discord. I'll make sure to answer them as soon as possible. And have a great day or rest of the day. See you in the next live stream. Bye.